All right, happy Halloween. Quadratic linear systems. Maybe they seem scary, but it's really not that big a deal. Quadratic linear. You know what a quadratic is. What's that a fancy name for? A parabola. You know what a line is. So before we get into the details, let's think like big picture about how many intersections there might be. If we're intersecting a parabola and a line, how many, and there's different cases, so there's not just one answer, how many intersections might I have?
2 or 3.
Okay, let's do 2. How would 2 look? There's my parabola.
X.
2 would just be like, if the line cuts across all the way, 2 intersections. All right, I like that. What other? That's probably the most obvious case, but there's 2 other cases. Do you know what the other cases might be? How else might we intersect a parabola with that line?
The bottom of the parabola.
Okay, so when you say
the vertex of the parabola.
okay, that's one like very specific possibility. I'm going to draw it not quite as specific, but you're on the right track. Like if the line is tangent to the graph, so it just touches it, and that could happen at the vertex, but it doesn't have to happen at the vertex. So you could have one intersection.
You could have the line go straight up or something.
If the line goes straight up, you'd have one intersection. That's true. That's also true. But is there a different number of intersections you could have?
Yes.
Yes, because I'm drawing something else. What's the other case? None. Right? If my line was down here, you could have no intersections. So we need to be on the lookout. Today we could have 2 solutions, 1 solution, or 0 solutions. That's kind of the big picture. So you might have 2 answers, you might have 1 answer, you might have no answers. Once we figure these out. Okay, 1 and 2. State if the point given is a solution to the system of equations. So how do I figure out if that point is one of the points that's an intersection? Let's see. Plug it in where? Yeah, into both. Like each of these points in this intersection is a point on the parabola, but it's also a point on the line. So if we're asking, does this point work, that means, is it on this parabola and is it on that line? So let's just plug it into both, and if it works, then we're yes, and if it doesn't work, then it's a no. So negative 3y squared minus 2 times 0 minus 7 times negative 3 minus 6 equals 0. I'm like question mark equals 0 because we don't know yet. We're testing it. Oh, negatives and squareds. What does this first term become? Negative 9. Square the negative 3, you get positive 9, and then put the negative on. So negative 9, 0 goes away, plus 21, minus 6, equals 0. Yes or no?
No.
No. Like you don't even have to you don't have to finish it, right? Like negative 15 plus 21, not 0. So that answer is no. I didn't even check the other one because it doesn't matter. That point is not on the parabola, so there's no point in checking the other one. It has to meet both. All right. My guess is this one will work because we probably have an example of 1 no and 1 yes, but let's see what happens. So 2 times negative 5 squared, 19 times 5. 2 times negative 4 plus 53.
19 times negative.
Oh, negative 5, thank you. Weird numbers, but we'll see. 5 squared is 25, times 2 is 50. 19 times 5, 95, right? Because 20 times 5 is 100, so 1 less 5 than that would be 95. Minus 8 plus 53. Again, I don't know yet. That's a lot of numbers. Let's see. Let's combine the positives. 50 plus 53 is 103. Negative 95 and negative 8. That's negative 103. So that one's a yes. But why am I not a yes for the answer to the question yet?
Because you have to check the line.
Got to check the line. So that point is on the parabola, but I don't know if it's on the line yet. So let's check the line, and then we'll have our answer. Negative 5 minus 2 times negative 4 equals 3. 8 minus 5 is 3. Yes, that's true. So yes. So those are kind of the easy ones. Just checking to see if a point is on both of the equations. The harder thing would be like number 3 here. Like I got to find the point or points that is on both equations. Solving systems. Do you remember the methods for solving systems? Substitution. You remember what the other method was? Elimination. You are still welcome to use either one, but because the parabola is involved, it feels like it's usually easier, safer, quicker to use substitution. Right? Elimination, that's the one you like, but it's hard to make it work sometimes, and it's really hard to make it work sometimes when there's a squared in there. So if you see elimination and you see where it will work, you're welcome to it, but I'm almost always going to use substitution because it's just easier on these problems. Okay, y squared plus 3x plus y minus 5 equals 0. X plus y equals 2. And I guess back up, one more thing about substitution. To get started, you'll solve one equation for one variable. One equation for one variable. And so you have to pick which equation do I want to mess with and which equation or which variable do I want to solve for. And it's your pick. You can pick either equation and either variable every time. It's just there's usually a good choice and a not as good choice. Kinley? I definitely want to use the bottom one because that's easier. So I definitely want to work with the bottom one. And then, do I want to solve for x or y? I would say either of them is equally easy. So I'm going to look at the previous equation. Would I rather substitute y things in, or would I rather substitute x things in?
Substitute y things in. Because it's squared.
If I substitute, I see what you mean. I didn't word that very well. Do I want to replace x with stuff, or do I want to replace y with stuff? Replace x. Because if I replace y, then you're looking at the right thing. If I replace y with 2 minus x, then I've got to square it. It's still going to work, it's just going to be annoying. It would be much easier to replace the x.
So you have to square a thing.
No, it's already squared. If I replace the x, then it's easy. So I'm going to solve for x. 2 minus y. Thank you. So y squared plus 3 times, now in place of x I'm going to put 2 minus y because 2 minus y is the same thing as x. So instead of writing x, I'm going to put in 2 minus y. Everything else stays the same. So y squared plus 6 minus 3y plus y minus 5 equals 0. So I've got a quadratic. Let's collect like terms and hope that it factors. Y squared minus 2y plus 1 equals 0. Does that factor?
-1, -1.
Yeah, y minus 1 and y minus 1. Y equals 1, that's a double root, speaking of double roots.
I did the square root. Oh, you use
You could use complete the square method, you'd still get y equals 1.
Yeah, I guess.
You'd get 1 plus or minus 0, I imagine.
You use factoring for that?
I use factoring.
Is it possible to use the quadratic formula on that?
Sure.
Oh shoot, I see where this is.
You would get 1 plus or minus 0. Your discriminant would be 0 because you only have one solution. Is that the answer to my question, though? Like, what am I looking for? I guess it didn't really say. What am I needing to finish this answer? The x, because I want to find the points. S in parentheses because there might only be one. So y equals 1. I'm going to plug that back in, basically anywhere previous, but there's a really good spot to plug it in.
Second equation.
Yeah, and I'd even go to this one. X equals 2 minus 1. So x equals 1. And then I need your answer as a point. So 1, 1. So this was a one solution equation. It's also weird, I didn't even see this earlier. Y squared, do you know what kind of parabola that is? The y is squared instead of the x is squared? Sideways. So we hadn't really done those, but that's a sideways parabola. We're only intersecting it at one spot, so I have no idea what this graph looks like, but it looks something like that. Number 4. Pick an equation, pick a variable. So which equation do you want to use? That's the easy one. Second one. Now, do you want to solve for x or solve for y?
Y.
Good. Why did you pick y?
Because it's only one Y.
Yeah, it makes life easier later. You could solve for x, but then it's going to be a mess. So let's solve for y. So if I move the y over and move the 2 over, I get 2x minus 2. Going to need to be careful about that lead minus sign there. Negative 2x squared plus 24x minus, I need to minus all of this, 2x minus 2 minus 62 equals 0. Okay, so negative 2x squared plus 24x minus 2x plus 2 minus 62 equals 0. A couple of things we could do next. What would you like to do next? Like terms? Okay. Negative 2x squared plus 22x minus 60 equals 0.
Divide by 2.
I like divide by 2. I would go one step further. Let's divide by negative 2. So the 2 we'll make it easier to deal with, but negative 2 will make it even better. So let's divide by negative 2. And then if you want to use quadratic formula, you can. If you want to complete the square, good luck, because you got 11 over 2 that you'd have to worry about. Hopefully your brain is such that you can look at that and think, oh, wait a minute, that factors. What are the factors?
X minus 6
Minus 6 and x minus 5. So x equals 5 and x equals 6. I think that means we're going to have two answers then. But we're not done yet. Not done yet. What else do I need to do? Plug them in and find y. And you can plug them in wherever you like, but if you're careful, you can usually find a good spot to plug them in. So if I just number these equations in order, 1, 2, 3, 4, 5, 6, where do you think would be the best spot to plug in those x's to find y?
Y equals 2x.
Yeah, the third one. It's already solved for y. So y equals 10 minus 2 is 8. Again, don't leave your answers as x equals 5, y equals 8. I mean, it's not wrong, but I want your answer as an ordered pair. Or ordered pairs, I guess, for this one. 2 times 6 minus 2, 10. So that one's got 2 answers. You don't have to draw the picture, but that tells me it would look, who knows, something like that. 2 answers. You guys are smart people. My first example had 1 answer. My second example had 2 answers. If we're being a good teacher and just giving 1 of each on the examples, how many answers do you think this third one's going to have? Probably so. Let's work it and find out. Well, let's start picking on some people since this is our third one. Trick or treat here.
Do you have candy this room?
I don't have candy. I have popsicle sticks. That's something, right?
I don't think I can eat that.
You don't. Someone already ate the popsicles, though. Layla, which equation do you want to solve? Do you want to use first? The second one. Yeah, that's all I asked. Which one? I would definitely use the second one. Max, do you want to solve that second one for x or for y? Why did you pick y? I agree with your pick. Okay, that's a pretty good reason. It doesn't have a 2 in front of it. What I was looking at was it's the easier one in the first equation. But you're right, it also doesn't have a 2 in front of it. So that makes it easier to solve. So 3 minus 2x. And I'll plug that into the first equation. Be careful with the 4. That 4's got to go to everything. So in place of the y, goes 3 minus 2x. X squared minus 3x plus 12 minus 8x equals 0. X squared minus 11x plus 12 equals 0.
No.
Well, I kind of gave away the answer here. If it doesn't have any solutions, that means it's not factorable. But you don't really know that ahead of time, so you're stuck trying to figure out how can I get 11 with, let's see, they'd have to both be negative, with some combination of these. So it's like 9 and 4, that wouldn't work. 12 and 3, 6 and 6, 18, 12 and 3. So like you could play with it for a while, but it's not going to factor. If it doesn't factor, what do you have to do? X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Good one?
Can I just use the quadratic formula for all of them?
You could. Yep. I feel like that's more work than is necessary for people who know how to factor. 121 minus 4 times 3 is 12. 12 times 12 is 144. We're about to bail out on this problem. Because what's 121 minus 144? Yeah, that's going to be negative. I don't even care what it is, because that means I'm going to get an imaginary. An imaginary, I can't have imaginary like solutions on the graph. So as soon as I get a negative in the for the discriminant, I can't have imaginaries, so no solutions. Or in fact, what you might want to say is no real solutions. No real solutions. And we don't care about the imaginary ones, so we just say, we're done. So it's kind of annoying you have to use the quadratic formula, but you kind of get bailed out because a negative under there means it's not going to work. Okay, so on to the worksheet. Again, today's assignment is the odds. 2, 3, 4, 5, 6. That's all of 6 problems. Monday's assignment will be the evens, but we'll also have a quiz on Monday. So we'll probably do the quiz first. No, we'll answer questions first, then we'll do the quiz, and then if you finish, in 10 minutes, then you'll have time to work on the evens.
Is it still a group quiz?
It will be a group quiz still, yeah. And it's only, I'll just tell you, the format of it is 5 questions, solved by completing the square, write a quadratic function in standard form with given zeros. So that's like the backwards problem. Like here's the answers, work backwards to the equation. 2 solved by factoring. So got to be able to factor. And then 1 quadratic formula. So it really shouldn't be that hard, especially if you have each other to help and check and make sure you didn't mess up something silly. So I think you'll be good for the quiz on Monday.
Do we choose our group this time?
What's that?
Do we choose our group this time?
It's going to be by group work. I mean, check with whoever you want to check with.
Oh, okay. So it's not.
So I'll force you to work solo for 15 or 20 minutes. So like you can kind of self-diagnose, hey, I know this stuff, or oh crap, I forgot the quadratic formula. And then you can work with a friend or a group or everybody to fix whatever mistakes you found. So we'll do it that way. All right, there's still 10 or 12 minutes left. I don't know, could you do one of these per minute or one for 2 minutes? No, but you could try number 1 and number 3.
They're probably easy to solve. It just takes a long